Hello everyone, this is Mr. 13 Things, and we're here in the middle of a discussion about teaching and embedding three-dimensional mathematics, simple matrix mathematics with students at about the same time they're doing it on their Xbox, PSP, whatever, or paper dolls or guns. And so we've started going through a discussion of how anything can be at some core way, even though it's not perfect, broken up into little triangles. Triangles are defined by three sides. The sides are each defined by points. So if we can deal with individual points, we can deal with any shape in three dimensions. What I'm going to do here, I'm going to recolorize now. I'm going to start back from zero. We're just going to deal with one individual point here. So I'm actually going to go File, New, and Start. I'm not going to save the picture. I'm going to say, I don't want to do that. There's my name. Don't want to do that. All right, so now we're going to start, and we're going to colorize a little differently. So I'm going to go ahead and go back here and pick a color. I'm going to make my triangle green, and we'll leave with that. All right. I'm using a Wacom tablet, which I think works okay. So I'm going to basically, we've got a coordinate pair. That there we know is 0, 0. If we think about it, realistically that point is 0, 0, 0, and 1. All right, so that's how we deal with that. But we're now going to deal with this point here. I'm going to colorize a little bit different. That point there, I'll go ahead and stack up the vectors. And this time, I'm going to use some more standard colors. The X is going to be red, and that's a standard color in CAD and science nowadays, it would appear. The X is going to be -1. Okay, the Y is green, so I'll just make that -1. And the Z, it turns out, a standard color for Z is blue. So I screwed that one up. I'm going to go ahead and edit, undo, edit, undo, edit, undo. I need to change my color for that one to green. So that's going to be -1. X is red, Y is green, and Z typically, believe it or not, there probably is 0 is blue. Okay, so we have X, Y, Z defining that point there. And that last one, of course, we can go back and try to make it black again, I guess. And we're still going to have that 1 there. We'll leave with that. It's interesting where that's going. Don't know where. All right, so when you colorize this, you're colorizing it for a reason now. As we come over here, I'll go ahead and now remember that we can transform anything by the number 1. But we're going to colorize how we write the number 1. Remember, we started 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. But this time, we're going to make all the 1s be the same color as that. And it's just really not necessarily so important, because in reality you're going to use a calculator or a computer to do this on your Xbox or in your class. So if you remember how that worked, it was 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, and then 0, 0, 0, 1 over here. So the 1s are going to be red, and you're going to see why later. The next column, if you remember, we can now grab this. We'll go ahead and make it green, if we would. And we'll now make that, if you remember, that was 0, 1, 0, 0. This next one we're going to make blue, because that would be the kind of the concept of the Z, right? 3 different colors. And we're going to make that, right, 0, got to learn how to run the machine. 0, got to learn how to suck up the ink. See if it works this time. Try it one more time. Losing patience, like your students might. So I'm going to go back to here and 0, 0, 1, 0. And if you notice these here, really they could all be the same color. What we want to finally do, however, to help color differentiate is now for these last numbers here, we want to recolor them to be red, green, blue. And you'll see why, hopefully, in a second. And so we're going to go ahead and use our colorizer here. And we're going to go ahead and put that one there to be, it's not letting me do it. So I'm going to go back to here, suck up the red, go to the pen, Sometimes you got to jump back and forth on the pen. So this is going to be a 0 here. We're going to suck up now the green. Right, go back to the pen and back. 0 here. And then we're going to suck up the blue. Right, suck up the blue. Go back and forth between there, and then we have 0 there, and I guess we can always make that a 1 whatever color. Now, you're doing this for all kinds of different reasons, and this next bit is really probably best taught by crowdsourcing. But what you're going to do is you're going to be multiplying or transforming, better said transforming than multiplying, transforming this point by this transformation matrix. And of course you got to get the transformer movie in there and all that stuff. And you're essentially, it's the same as multiplication, and you can kind of go as deep as you want, but you can very quickly teach students to use some technology to do this after they've gone through and done some of these color matching. And so I'm going to go ahead and just kind of go through for you who don't remember that this is a 4 by 4 matrix, and this is a 4 by 1 matrix. And when you multiply a 4 by 4 by a 4 by 1, the rule of matrices is these two numbers have to be the same, and you end up with a 4 by 1 matrix. Now we know what the answer is, and at this point you can teach students what's great about this problem is it's great to ask yourself a question you know the answer to. And if this is 1, the identity matrix, and you're transforming something by 1, it's going to be the same thing. But make them prove it now, and this is how they prove it. We'll have to show this in animation, but essentially I'm going to try to make the colors match up. I'm going to take this 1 and multiply it by the -1. I'm going to say with the colors here, I'm going to grab that, right? Probably best shown by animation. This is going to be, once again, we're using the suck the color. We're looking here to see whether it catches. We go back and forth. This is going to be 1 times -1. Okay? And now the green. You're going to go ahead and, in this case, plus, 1 times -1 plus right 0, see if I can suck that up, 0, going back and forth, got to suck up the ink, right, back and forth, 0 times -1, right, plus ... So essentially what you're doing is you're learning to multiply this row by this column. You're physically picking it up, taking it down, marrying them, and then summing them on the first value. Doing the same on the second, doing the same on the third, and doing the same on the fourth. And you can realize when you do that, the students will very quickly realize, oh, that's how when you multiply this, this is the only one that counts. When you multiply this line or this row vector by this column vector, this is the only one that counts. And when you do this, this is the only one that counts. And so you end up, if you would, with the same answer, right, of -1, -1, 0, and 1. Very quickly, you want to teach students to do it by hand a few times, but then very quickly, this is one place that you are lying to them. That's a pretty strong word, but you are fibbing to them if you think that many of us ever do this in any other way than on a calculator. Something like a TI-83 or out of UW-Madison, Octave, or in a spreadsheet. Unfortunately, not Excel, but Google spreadsheets. If you let them know that multiplying by this is done any other way than by some technology, you're not necessarily telling the truth in reality. But the great thing is you can assign this calculation to one row of students, this calculation to another row of students, this calculation, etc., and they can crowdsource the answer. And that can be pretty useful as they start looking about how game design, and I'm saying game design here because that's what they relate to. How about landing spacecraft or coming up with geometry of molecular structures? This is all done by 3D visualization. Visualization nowadays, that's a big part of it. And so understanding that you can transform any three-dimensional point with an extra thing stacked on the side by a four-dimensional matrix, which is, you'll see later, which is comprised of something here combined with something there, and this is where you get the colors. So this is kind of one sub-piece of this, this is another sub-piece of this, and this is all just placeholders. So when you start applying this set of calculations to single points are attached to edges, which are attached to faces, which eventually are attached to 3D bodies. You've taken students a long way into their Xbox, and they can own the mathematics and understand that computing and using mathematics to do incredibly fun stuff is not necessarily something that we should wait until senior year in high school to grasp outside of our Xbox. Thanks for listening.